Alrighty guys, module number 6, we're gonna get into some intermediate areas of Python. So today we're gonna be introducing the use of standard and external libraries. So bravo on reaching the end of the course. I hope you guys have learned a lot on the intro to programming and Python bootcamp that I put together. Today we're gonna be looking at Python's treasure trove, which are its standard libraries. We're also gonna be looking at libraries that we can download that are not native to Python, such as Pandas, NumPy, and a bunch of other different libraries. These libraries contain a vast collection of pre-built modules that offer functionality for various tasks, such as handling dates and times, performing mathematical operations, working with network communications, doing data analysis, doing charting, etc. We can leverage these standard libraries that will save you time and effort in developing a robust and rich application. So get ready to unlock the true capabilities of Python now that we're able to import certain libraries. There are going to be certain things that we can utilize and kind of lean on for. The open source community for Python is amazing. So there are endless libraries that you can utilize other people's code to help empower your code. So let's strap in for the ride and let's learn about it today. Hone in on your skills that we've learned over the past couple days, weeks, or months, however long you're taking to do this prep course. And let's just jump into the presentation. And thank you guys for staying along for the ride. I appreciate all of the feedback on the course, and I hope you guys are really enjoying this and learning a lot. So let's jump into the PowerPoint presentation as always, and let's do it. Alrighty guys, so this is going to be our libraries, packages, and modules portion of this specific bootcamp. Today we're going to be learning about some external libraries inside of Python, and let's get into it. So just to get started, the reason why I'm saying we're going to be learning about all of these, we're really going to be learning about libraries today inside of this bootcamp prep course. Libraries essentially have a bunch of packages which have a bunch of modules inside of them. So I'm going to be referring to them as libraries for today, but feel free to look into those differences and those things. So first, we're going to be learning about the internal libraries that are native to Python, like importing math, importing date time, etc. Next, we're going to be learning about external libraries, and the ones we're going to be learning about today are Pandas, NumPy, and other useful libraries. We're going to be focusing on Pandas and NumPy today to get you guys prepped for your courses at FAU, but I'm going to include some other ones that I feel are useful. And again, if this course does really well, maybe we can do a more advanced or a more in-depth bootcamp for Python, or just continue to keep learning in Python. I love to use it every day, and it's a part of my life, just like Excel. So I included a meme as always. Pandas love data science, a little pixelated here, but no problem there. Let's move into the lecture and then the workbook. Alrighty, so hands-on as always, I'm going to be using Windows. We'll be working in our Jupyter notebooks for today. And if you have any questions during the hands-on tutorial, please email me at matthewngUYE2023@fau.edu. Alrighty guys, what are libraries? So libraries can either be standard or built in. In the internal libraries portion of this lecture, we're going to be talking about these. So these are Python has prepackaged libraries that allow you to do a bunch of different things. The main ones we're going to be focusing on today are math, date, time, and then potentially looking into some other ones as well. But let's just look at these. These are some of the examples of the ones that I included here. They include a wide range of modules that run on all the different types of Python distributions. So Jupyter Notebooks, PyTorch, Google Colab. If you're going to be writing Python, you're going to have access to these, so do not fret. So take a look at these and get a good understanding of these. Next, we're going to be looking at external libraries and packages. These libraries that are not included with the standard Python distribution and sometimes need to be installed separately. If you're working in our Jupyter Notebook, you'll have access to all of these inside of Jupyter Notebook, the ones that we're working with today, which are Pandas and NumPy. But if you don't need to, if you don't have them, you're able to install them by just clicking pip install and then the library name. The ones that we're going to be looking at are NumPy and Pandas today, but these are some other ones that I like to include as well for you to do some learning on. So requests, or you can make HTTP requests to servers, matplotlib, which allows you to visualize your data, and then scikit-learn, which basically allows you to start dabbling in some machine learning and algorithms and whatnot. So let's take a look at how to use these libraries. So in order to use these libraries, you want to use a direct import. So it's basically just going to be importing the library name. Example, if we want to import math, we're going to say import math. After this, you're going to use this math library by referring to it when you call it on a specific function or a specific set of data that you want to use it on. For instance, if you want to calculate the square root of a number, you would just do math.sqrt and the number 9. So that'll get you the square root of 9. We like to import our libraries with aliases when possible. For example, if you're going to be using Pandas, a lot of people use the alias PD. So you're just going to say import Pandas. So instead of having to do pandas.dataframe or whatever, you can just use pd.dataframe to create a data frame. So if you want to import specific modules or functions from these libraries themselves, what you can do is you can do, again, the library name. So you'll do the from library name and then importing the specific function or module that you want to import. So from math, import square root. But I find it easier sometimes just to import the entire library. If you're not worried about memory allocation or anything like that, then you could just utilize those as an entire library. Remember, when you use a library, you want to make sure that you have everything installed. Like I said, you want to use the pip install. You can also use the exclamation point to run the statement in the shell as a shell command. Kind of technical here, but for the most part, just do pip install and you should be good to go. Alrighty, so let's take a look at Pandas. So Pandas is a popular open source Python library that allows you to access data, whether that be from a CSV, whether that be from an Excel workbook, and it allows you to visualize this data in a table format. It formats your data into something called a data frame, and you can analyze this data using some of their Python commands. I included a meme here, Pandas love data science. It is an ongoing joke that you probably have overheard if you've ever looked into doing any of this. So Pandas, let's look at some of the important topics here. I'm just going to pull them up all on the screen. So we want to take a look at the data frame being the number one Pandas topic that we're going to be focusing on, is really understanding what a data frame is. So basically it's going to be like a table. It is different from a NumPy array because it contains inputs that are all within the same object. Series is going to be a one-dimensional object similar to an array, list, or column in a table. So make sure you understand that. Next, inside of Pandas, we're going to be talking about data manipulation. So this is where you can slice and dice your data, allows you to merge tables together, reshape your data, and a lot more things. You can also read and write data inside of Pandas. So again, you're able to take data from databases, CSV files, Excel files, etc. You can handle missing data. For example, if you have missing data inside of your Pandas inside of your Python notebook, you can use a way to replace NA values or blank values. You can filter your data within the Pandas library inside of Python, and you can also do some analysis on your data. This will help you build your skills in financial analysis, statistical analysis, data analysis, etc. So make a lot more sense when we get into the workbook. Just going over some of the basics here so you guys get a full understanding, and then we'll jump into the notebook. So don't worry, it is coming. Alrighty, so I want to show you guys what a data frame looks like visualized. So very similar to an Excel table. Remember, the index will start at 0 here, and basically it's going to allow your Python code to compile the data in a structure that will allow you to utilize your various different functions and loops and whatnot to aggregate and manipulate this data, and it'll be easier for you. Alrighty, NumPy. NumPy is short for numerical Python. It's a core library for scientific computing inside of Python. It's an easy to work tool. You can do a lot of things like linear algebra inside of NumPy. The biggest thing inside of NumPy is their array structure. So just think of it as a list in a sense. However, there are some nuances and caveats to that might be a little bit too far for this specific course, but just think of them as lists, and they allow you to create 3D lists, 2D lists. Let's talk about the meme. It's showing the SpongeBob episode where Squidward doesn't want to take a bite of the Python, which would be the hamburger, but then he realizes that he has Jupyter Notebook, NumPy, Matplotlib, and Pandas. So again, these libraries are extremely useful, extremely crucial when you're learning Python and when you want to go beyond to the next level. So make sure you get a good understanding of how they work today and then apply them to the practices that you'd like to in your future. Alrighty, NumPy arrays. So like I said earlier, a NumPy array looks like a list inside of Python, but it's different. In this case, we have a two-dimensional NumPy array. We have a list inside of a list. We have a list in Python terms, or what it might look like to you, is that we have one big list. Inside that big list, there are two smaller lists that have two smaller lists in them. And this is how it will look like visualized as a NumPy array. So here are some things that I think you guys might get some value out of taking a look at NumPy on a high level. We're going to be going over multi-dimensional arrays today. The stuff that I highlighted, the stuff we're going to be going over. There's mathematical functions inside of NumPy. So we're allowed to actually multiply arrays out. We're able to do some linear algebra in this case. We're able to calculate some statistics. Do some matrix operations, which might sound like a calculus or a algebra recap, and it might bring back some PTSD on that, but don't worry, we'll make it easy and simple for you guys to understand. And we can also integrate these with other libraries like Python, like Pandas or Matplotlib, and they're super useful to use together and use them in conjunction. So make sure you strap along and get ready to go. Alrighty guys, so these are some other useful libraries and modules that I wanted to include here. I'm not going to read them out, but feel free to take a look at them. These are the ones that I've used in the past in my workspace. So make sure you take a look at these and kind of understand how they work. They're very useful when you're going to be working potentially as an analyst, as a developer, and whatever you decide to do after your time at FAU. So take a look at these, learn these. Some very good resources online. Maybe one day I can even go over some of these in another bootcamp course. That would be amazing. So as always, before we jump into the workbook, I want to say thank you guys. Here, read my farewell note. So make sure you always enjoy writing code. It's going to be very, very difficult at first. It might even be difficult after this bootcamp. I think the time that we have allotted for this bootcamp is a couple days, but it's going to take a lot longer for you to learn how to code properly and learn the good fundamentals of this beautiful art form that we call programming. So make sure you always stay dedicated to this, continue to keep learning, use real life examples. If you can get a job quickly as a programmer, even if it's not super high paying and you want to get into this field, take the experience when you can, work with large data sets, understand how to perform analysis on data, understand how to do data mapping, understand web scraping. These are all really big tools that are going to pay the big bucks later in life. And the more that I learn with programming, the more I've learned about problem solving. And that's one of the biggest things that you get from learning how to code is to actually learn how to problem solve, which is a very useful tool, not only in programming, but in life. So make sure you take these concepts, apply them to projects, go on YouTubeuniversity.com, watch videos, enjoy the courses you're taking here at FAU, and really, understand why we're learning how to code, why we're learning how to transfer data, why we're learning how to utilize things like JSON for passing data along, why we're able to make requests and use things like endpoints, calling different endpoints with functions and returning and passing data in real time, doing calculations, and all of these things. I can talk about it for hours, but make sure you really take all these basic skills in and hone in on them, really understand why we're doing this, why you're writing code, why it's useful, and I promise you your journey on getting a job and landing a role that pays you very well, or even paying it forward, teaching one day or whatever you decide you want to do. Make sure you always take this fundamental course and just build on it and don't let it go. I promise you it's well worth it, and I've been doing it for some years now, and I wish I would have started earlier. So I hope you guys have enjoyed this course so far. Let's jump into the workbook. Let's knock out some of these Python libraries and let's get you guys wrapped up and ready to go. Alrighty guys, so we are not in the Jupyter Notebook yet. I wanted to show you guys 2 pages that you guys can check out, and also let's just do another one. Let's do Python documentation. So we keep it raw with you guys. I want you guys to take a look at these 3 web pages when you're utilizing Python, NumPy, any package, any library you decide to use. You want to make sure you always take a look at the documentation. So you can go to the webpage docs.python.org/3 to read up on Python, any of the newest updates. The same thing goes with NumPy and Pandas and any other library or module you decide to use inside of Python. So what you want to do is you want to actually just navigate around here, and you can actually read about the different things that we're going to be going over in this lecture, but in full detail. This is literally coming from the horse's mouth, or whatever the saying is. This is the key to being able to learn how to be a good programmer. You can watch tutorials, you can do a lot of things to help you learn, like watch this bootcamp. But the biggest thing that has helped me and that I always go back to is reading the documentation. The reason is because this is literally where you get the information on the libraries, the modules, the packages that you're installing, and they give you all the information you need. You just have to take time to read it, analyze it, understand it, then maybe go watch a tutorial, then implement it on your own. So I wanted to show you guys these, these different documentation notes and guides here. So let's get back to the core of this video, and let's do libraries. So today, let's take a look at some libraries that we are going to be looking at today. Internal and external libraries. I got some code here, I got some questions that we're going to be going over. So what I like to do is I like to typically import all of my libraries, modules, or packages in the first line of my code, or the first block of my code. But today I'm just going to be doing them in the individual cells. But I want to show you guys this too. If you do not have any of these for some reason, you'll have the import for the math, the randoms, and the datetime for the internal libraries. But what you want to do here is you want to be able to understand why they're coming in and how they're doing it. And the only reason they're in here is because this script was originally run before we even downloaded Jupyter Notebook. But let's say I want to install Pandas. All I have to do is pip install and then the name of the library, module, or package that we want to use. So pip install Pandas. You're going to see I'm going to run this. It's going to say it's already installed. But it's going to be loading for a second. Okay, so this is requirement already satisfied. So when you decide to install a package, module, or library that hasn't been installed yet, I guess I already had Keras installed here because I've used it before. But anyways, let's move on to the internal libraries. So again, we're going to import math in here. In this case, this is an internal library. Let's click run. Actually, let's comment these out so I can show you guys line by line. So when we do the import math, we're going to print the square roots. This is one of the methods you can run, or one of the functions that are inside of the Python internal library of math. So no more having to do things like squaring or things like exponentials. You can actually work these in, and we'll show you in a second. So I'm going to uncomment this. There is the log function here, so you can import the math library and have the log here. So in this case, for the math.log function inside of the math library, we have the logarithm at the base of 2, with 16 being what we want to get that. So we click run, and we'll get 4 in this case. So you can use that. We can also get the value of pi. So let's click run. We get 3.14. We can also do this and get E. Click run. We'll get 2.71. Some cool stuff in here, so you don't have to define pi as something different. You could just have it already installed or made for you. Next, you could do something like the power, so no more power 2 as we have tried before. So we can just do 2 to the power of 3 in this case. Let's click run, and we get 8. Alrighty, the next one we're going to look at is random. So let's do import random. In this case, we're going to have a random number. So we're just going to have a variable here called random float, and we're going to do random because that is the name of the library we have. Random.random is going to get us a random number. Let's click run. So we got this random number here. Let's go to the next one. So we can have a list, and we can have the random library shuffle our list, so we can actually have it come in different order. So if I run this again, it'll shuffle it differently, and again, this will become a different random number. The last one is random choice, so we can feed it a list in this case, and it'll give us a random data here out of this list. So let's click run. We get a different one every time. It's a very useful library when you're trying to do some randomized functions inside of Python. It gives you random numbers or random weights for specific analysis if you want to do it that way. So really cool functionality built into Python. Alrighty, so let's look at datetime next. So we're going to be importing datetime as datetime in this case to show you guys how you can use the as keyword here. In this case, we're going to print today's date, and then we can also feed it a date, and it'll print that date too. So let's just click run. In this case, we get today's date, and we get the date that we feed it. So let's say we want to calculate how many days ago a specific date was. Let's write a function to do that for us inside of Python. So let's start with specifying our date. So let's say date as a string. So date string is equal to 21 of, let's say, June of, let's say, 22. And what we want to do is we want to format this date. So this is going to be boilerplate. Remember this code. So we're going to have %sign D for the day, dash %sign B for the month, dash %sign Y for the year. So let's do date equals datetime dot datetime. We're accessing a module inside of this library dot strp time. So
strip time, and then we'll feed it the date string, which is going to give us the date, and then we're going to get it the date format. This is a built-in function inside of the date time library. So let's print the date. We get the date. So we get that date formatted as the string that we would like. So from here, what we're going to do next is we're going to calculate how many days ago it was. So we'll do days ago is equal to datetime now minus the date dot days, and let's print days underscore ago. Let's run this, and it was 409 days ago. So it works pretty well. This is a very important portion of the internal libraries you guys want to focus on. And remember, if we decide to clear the kernel, in this case, if we make a mistake, we want to rerun these cells where we imported the different libraries. In this case, I had a string error, so I had to restart it, and it could throw you an error if I decide, let's say I want to restart this entire kernel, and I try to run this, trying to reference the datetime library. It's going to throw me an error. It's going to say datetime is not defined, and that's because I did not import the datetime as datetime in this case. Let's restart everything, and let's move on to external libraries. Let's move on to the big animal, the big bear, Pandas. Alrighty, guys, so in order to do this, we have to take a look at what Pandas is, and Pandas is a data analysis tool that will allow us to manipulate, transform, and structure our data. So in this case, what we want to do is we want to look at this block of code. So we want to look at the block of code, and let's actually pull this out and put it into a cell above in case we need to rerun this so we don't have to continue to keep running that cell above. So let's paste this here. We're going to import Pandas as PD. Let's click run. So now Pandas is imported. I'm going to comment out some of this other code so we can go through it line by line. But as again, I said, it's very important to read the documentation so you make sure you get all of this stuff right. So let's take a look. So in this case, we're going to have a variable called data. We're going to be naming that data as a data frame here. We're going to declare it as a data frame in this case. But essentially, we just have a dictionary here, which we have the name, and then we have the list of names as the value in this dictionary. And in this case, we have the age as the next portion of the dictionary, the next key, and then we have the values of the ages of these people. So what we can do here is we can say df, which is pretty standardized. Df equals pd.dataframe, which is going to put it into a data frame. So let's just print this and see what happens. So we get this nice structured data, almost looks like an Excel sheet. And we can also do something like print df.head, which gets the top piece of data, but we'll go over that next. So basically what we want to do here is we want to take a look at this next block of code where we have a print statement here. We can say df, and then we get the df, which is giving us the key in this case, the age, and we're saying if the age is greater than 24, then print that part of the data frame. So let's run this. In this case, we get Anna and Peter since they're over the age of 24. So that's one of the examples you can use for Pandas in this case. Let's take a look at the next statement. So what we can do here is let's actually uncomment this out. So we're doing an F string here. We're saying the number of duplicate rows, excluding the first occurrence. And we can use this specific portion of Pandas, which is it's a line that prints the number of duplicate rows in a data frame, excluding the first occurrence of each row. So we use the df.duplicated method, and then here we're calling the sum of those. So it counts the number of true values in the series. In this case, when we run this, you'll see, so let's click run. The number of duplicate rows is 1. It's counting how many duplicate rows there is. And then we can do something like this, which drops the duplicates. So we just do df equals df.drop duplicates. So as you guys can see, John is repeated twice here. So let's uncomment this out, and now we're renaming that first variable as this variable. So now this will be the df in this case. So let's click run, and now we got the name, age of these unique key value pairs.
So let's move on to the next portion of this part of Pandas. I'm going to actually clear this cell just so you guys can get the ending of it and not have to see it real quick. So in this case, we're going to be loading a CSV that we have in our data frame. In this case, we have a CSV called employees data that you guys have access to. And I wanted to show you guys something. So if you don't do print in this case, you'll have the data frame as its raw format from Pandas. So let's just click DF. So it looks like an Excel table or an SQL table, depending on what you're familiar with. So you can look at it like that if you don't do the print functions out of Python. But we're basically going to be reading this CSV just like we did in the last chapter. We read a CSV. Pandas has the ability to read CSV. So let's clear this output so you guys can not see that. Alrighty, so let's say we only want to print a first couple rows of the data frame because there's a lot. We just want to get a quick look at it. We can do print df.head, or I'll take this print out and just do df.head. So let's run this. So we see the first couple lines of this data, and we can kind of look at it without having to have that giant output of a bunch of different things here. So that's always useful when you want to take a look at the data and see, okay, this is what it looks like. And it's a little bit more visually appealing than this type of data frame, which is just this. So that's something to think of. Now let's take a deep dive into actually using this for something that might be useful. So we got all this data and we have this thing called Pandas. How do we make it useful? So in this case, let's actually make a function to calculate the average salary by the years of employment. So let's click B. Let's start writing some Python and really starting to utilize the powerfulness of Pandas. So what we can do is let's take the data frame that we created in the cell above. So let's say df. Let's do df.style.set, where we can set some properties to our style to make it look a little bit more visually appealing. And let's just do ** in this case. And basically we're going to be feeding it some CSS in a sense. If you don't know what that is, don't worry about it. But let's just do something like the background color. Background color. Let's make it color. Background color. Let's do black. Let's do a comma. Let's do the color of it. Let's say blue, comma, and let's do border, color, let's say white. All right, let's see how this looks now. Let's close this out. It looks like a dictionary, but I mean, I guess you can consider it a dictionary. All right, let's click run now. So we have the data frame and it's styled in a manner that's a little bit weird, but I wanted to show you guys how that could work. Let's change this to gray and let's click run. So you have a gray background here. Maybe let's change this border weight to black. So you can stylize your data frame as you feel is fit. All right, so that's how you format a data frame. Not the prettiest thing in the world, but I wanted to show you guys that before we get started with this exercise. So let's take a look at this exercise and let's do it. So we want to calculate the average salary by years of employment. So what we want to do here is we want to convert the string of the hire date to an actual date. So we're going to do df, and we're going to choose the name of the column, which is hire date. df hire date. Paste this into here. And we'll do equals PD, which is pandas, to date time, parentheses, df, and we're going to take that hire date again. So we'll copy this hire date. Paste that into here. Hire date, and then we're going to be formatting equals, again, that percentage D space or slash percentage B slash percentage Y. It'll turn us into the same format that we had up here in the date time. And this to date time
method that we're calling on the PD, the Pandas library. It's going to turn this into the date time that we want. So let's run this and see what we get. So we're going to get the dates in a proper date format, the one that we want to use to do a calculation rather than this June here date. So that worked out well. Next, what we want to do is we want to do df, and let's take the df, let's do years employed, which is going to be a new variable or a new key. Let's make it all caps. Years employed is going to be equal to, again, remember date time dot now, which is going to get us today's date. And we're going to subtract that by the df higher date, which we just changed. Subtract that by the df to higher date dot dt dot days. dt dot days, we're going to put this comma back up front. Okay, so we're getting the date time minus the higher date in this case, and then we're going to divide this all by 365. You could do 365 and a quarter for leap years, but let's not worry about that now. So let's run this. So in this case, we're gonna get the number of years that they're employed for. So that makes it a lot easier to do this analysis on. So now we're gonna do the average salaries by year. So let's do average salaries by underscore years is equal to df dot group by, which is going to be a method in Pandas, and we're going to do df, and we're going to do the years employed dot as type. We're going to feed it as an integer in this case. And we're going to close this out. And we're going to say at the index of the salary, and we're going to do dot mean. So we're getting the average here. Let's just print this to see what we get. Let's just run this. So we get years employed, and this is how much money they make per the number of years that they get employed. So we're taking the floats here and we're turning them into an integer. We're getting the salary in this case, and we're grouping them by the years that they've been employed for. So let's say we want to just print this. Let's do a for loop for years salary in the average salaries by years dot items. We're going to print, let's do an F string in this case, average salary of this set of employees with years of employment is, and let's throw this, salary let's close this out and let's click run. Average salary of set employees with 15 years of employment is this, and we can also just do this, comma, throw a decimal place here. Oops. I am doing overwriting to F this. All right, to F as a string. Let's click run. Now we got the average salary of employees to 2 decimal places. Let's just say we want to get it to none. Let's click run. And we get the average salary based on the number of years they've been employed. These people should be paid more. It doesn't seem like they're getting paid much. Alrighty, guys. So let's say we want to find the highest salary out of all these people. Let's just do max salary is equal to our DF. And let's do salary. Dot max. And let's print max salary. Let's run this. So our max salary is $24,000. Wow, not much. But anyways, guys, this is the basics of Pandas. I hope you guys can see the usefulness and how it can be used in manipulating and transforming and analyzing data. We haven't even really scratched the surface with Pandas, but unfortunately, we got to move on to NumPy, guys. Alrighty, guys, let's get into NumPy now. So as always, let's import NumPy. We're going to import it as NP. I'm going to add a line here just so we don't have to do this over and over again. We're going to run that. So inside of NumPy, what we can do is we can actually create arrays, which this might look like a list, but you'll see why this is useful later with the computational power of NumPy arrays. So let's take a look at this first line. I'm going to comment these other lines out. So we'll click run. And now we get this as a NumPy array. So the elements are separated by spaces and not by commas. And that's that. Alrighty, let's take a look at the second one. So we're going to be multiplying each value in this array by 2. So let's click run again. And now we get each value in this list that was here in multiplied by 2 in this NumPy array. NumPy arrays are utilized so that we're able to computate multiple functions and calculations on specific elements in these 2 and 3D lists potentially. Alrighty, so we can also calculate the mean of an array. In this case, let's run this again, and we'll get the mean of the NumPy array. So we'll get the mean of all these numbers in this list put together. Alrighty, guys, so let's take a look at another functionality inside of NumPy, and that's making a random array. So we can do np.random.rand, and we'll create an NumPy array of 10 elements. Now let's take a look at that. My array. Let's click run. So we get the array of these random numbers, and then we can also calculate the minimum and maximum value of this NumPy array. Now this array will change on each iteration, you'll see. So I click print min value and print max value. So let's click run, and we'll get this different every time. If I run it again, it'll be different because it's creating a random array after each run. So the crucial part of NumPy is actually being able to create dynamic arrays and then 3D arrays and 2D arrays and a bunch of different data structures that you can create within NumPy. So here I'm doing I'm creating a variable called data, and I'm creating a random NumPy array. In this case, when we run this, and let's print data. In this case, it won't auto update if I run this again because I'm not running the first cell again. So this will stay the same. In this case, it'll create a 3D array with the dimensions 3 by 4 by 5. So the first dimension 3 is like having 3 different containers of groups. You can think of 3 different sets of 2D matrices. The second dimension is within these containers, you have 4 rows, and you have 5 elements in each row. So, or 5 columns in this 3D array. So simple enough, we can actually get the type of what this is. So if we print data up here and we have the type of the data, we get a NumPy array, which is awesome. Next, we can get the shape and the size and the type of data within that 3D array. Let's click run. So the shape, we get that same shape that we fed it up here. It's 3, 4, and 5. The size would be 60. The reason is because we have 20 elements in each part of this the 3 different containers. So as you guys can see here, that gets us the size, and then we can print the actual data and get a float since these are decimals. All right, let's take a look at this. So what we're going to get here is we're going to get an array, a NumPy array with a bunch of zeros in them. The same thing goes for ones. And the next one is going to be a NumPy array that has 10 elements, and it's going to be full of 5. So let's run this. So we get this, we get the zeros followed by a dot, we get the ones followed by a dot, and then here we have the 5s in a 10 element form. So might be a little confusing at first to understand why this is important and crucial, but I'll show you in a second. And here we have a coefficients matrix. So if you guys remember linear algebra, we have a NumPy array with this structure. And then for B, we have a NumPy array of 1, -2, and 0. Now we can use the np.linalg.solve method and function to actually feed it the first variable and the second variable. And if we print x, we are going to get this solution. So we actually get the solution to the matrices. So if I change this to like 10 and click run, we get the solution here. If I change this to 10 as well, we'll also get the solution. So really cool, really dynamic things you can do for NumPy. Now let's get into a practice exercise so I can show you guys how this might actually make sense and practically be used in an exercise. And we will close out today's lecture. So in this exercise, we have a list of students, and within that list, we have a bunch of other lists. So what we can do here is we can actually create a NumPy block code using NumPy and get the average by the student. So let's say this is student 1, and then this is student 4, student 2, student 3, and we can calculate the average across each student, and then we can calculate the average across each test. So how would we do this? Let's say scores is equal to np.array, and let's copy this code into here. And let's create a bracket here and a bracket here. Let's separate these each out by a comma, very important here. All right. Now let's say we want to get the shape here. So let's just say shape equals scores.shape. Let's run this. Let's print shape. Let's run this. We get a 4 by 3. As you guys can see, 1, 2, 3, 4. 1, 2, 3. So that looks correct. Now let's say we want to calculate the average score for each test and the average score for each student. So what we can do here is let's make a variable and let's call it average scores per student. And that could just be equal to np.mean. We'll take the scores NumPy array that we made, and we'll say the axis is equal to 1. The reason why we're doing axis equal to 1 is because we're going to get each score by each student in this case. And let's do the average scores per test. It's going to be the same here, np.mean scores. Instead of axis 1, it'll be axis equals 0. That will get us each specific column in this case, which will get us a test, the average scores by test. So let's do a print statement here. Let's say print average scores per test was, comma, copy this, comma, while the average scores for each student was, comma, average scores per student. Let's print this. Oops, wrong variable name. AVG. Let's change this to AVG. AVG. Let's click run. Average scores per test was this, while the average scores for each student was that. So easy and simple enough. You're able to kind of understand how NumPy arrays work and utilize them in a practice exercise. I hope you guys can look over all this material and understand how it's useful and how it can be used in Python and how it can be used to create functions, even create things like loops and go through each and every component of the Python course that we learned. Hope you guys enjoyed each and every part of this lecture series. Thank you guys for joining Module 10. Thank you guys for joining Lesson 10, Module 6, Intermediate Python. I'll hopefully catch you guys on a bonus video about object-oriented programming. And if I don't, thank you guys for watching this well-rounded Python bootcamp. And if you guys have any questions, also feel free to reach out to me at Matthew, MATTHEW, NGUYE 2023 at FAU.edu. Hope you guys enjoy your day. Take care, and let's learn more.